All right, I'm gonna do this. I'm gonna do this. I need this for myself. Sit next to Eli and Weston. Not they're bad kids or anything, but just to keep an eye on them.
Because we're good kids.
Can you grab that for me? It's just so. Perfecto. Okay.
That's as far as it goes.
Yeah. I'm just gonna put it underneath here, just so it's not. Like this. Yep, there you go. Not bothering anybody. Okay, class, let's jam. We're good, Weston? Keep an eye on Weston, keep an eye on Eli. We have symmetry. Now, we did symmetry before. This is a slide from before anyways. So question is this a function? That's what we're interested in.
Yes.
Yeah, it is a function. It passes the
Line.
vertical line test. Absolutely. And everything is great with that. So this is a function, except we're gonna have to give it a name. We're good? So, and we're gonna give it some kind of name. We'll see. But just real quick here, don't need to write these ones down. I'll tell you which ones to write down. Like the ones that I write down myself, that's the stuff you need to write down. But I was waiting for Ben to write a whole bunch and then tell him not to write it down.
Yeah, that is what happened.
Yep, absolutely. See, I know what I'm doing. Okay, so real quick here, not writing stuff down, just think with me here. Yes, this is a function. It passes the vertical line test. Everything's great. Ben, go ahead.
And what would be an example of a function?
Ah,
If it
good.
just were a circle?
Yeah, but let's get to that right here.
Yeah.
So these are not so much as testing whether something is a function, not a function. This is whether the symmetries that we learned the section ago, which ones are functions, which was not. So the symmetries only. So we had 3 symmetries, is that right? So symmetry, but the y-axis, everything's great. That means it's a function. The x-axis symmetry, function or not a function? So that symmetry, not a function. We're not even going to worry about that. That goes away on us. We're good. Next, symmetry about respect to the origin, function or not a function? It is a function, right? Because label an x and y here, it's just going to be its opposite in the catty corner quadrant here. Okay, so we need to worry about or think about y-axis symmetry and symmetry about the origin. So here's what we got here. So now you can write stuff down if you didn't write it down last time, because I was hurrying up last time on this one here. So symmetry about the y-axis. It is a function, right? And we're going to call it an even function. And kind of like it's symmetry about the y-axis, huh? So the basic sort of question or graph that we always think about in math is just x squared. So does that look like symmetry about the y-axis?
Yeah.
Yeah. All right, so x-axis symmetry, that's not a function. Don't need to worry about that one, but symmetry about the origin. What happens here? Symmetry about the origin. All right, we're going to call this an odd function. And in math, we talk about these guys all the time, even odd functions. And each one has their own separate properties here. But the odd function, the best one that we use for as an example is x to the 3rd power. So then just x to the 3rd. Again, that's just an example. It's not the only one, right? But that's just an example of it. All right, what should we notice off of this is you guys are still copying. I'll wait a little bit here. So even function. Remember how the x and y are here, right? And then if you plug in a really, one second, I have to do this all over again real quickly here. Speed writing. Okay, so remember how we, for the symmetry, we plug in negative x? Let's see what happens if we plug in negative x into x squared. So that little guy is x times x and y. That guy is a negative x, y. Notice the y's are exactly the same, right? They're the same height. Wait a minute. Instead of having y values, don't we have f of x? So this one, if you're talking about functions, you don't write it as x and y. You write it as x, comma, f of x. Because when you write x and y, that's just a graph. X and f of x, that means it's a function itself. So this guy would be negative x and f of negative x. See if we're good there, following along. Ben had a question.
Kind of a funny question. What is the function of functions in like the real world they use for?
They had that in the book.
They did.
The function of functions.
Or what you
I
can
just
do
thought
with
it'd be funny,
functions,
but
what
that
are they
function is a
useful?
function.
I don't know. So real quick, let's see what we have here. Don't we have y the same on both sides? So it kind of just says this. If you were to plug in a negative x, it's the same thing as plugging in a positive x. Because they're on the same level, they're going to give you the same answer either way. The other one over here, x and y. And then we plug into here, we get a negative x, negative y. Because of symmetry. Tell me if I'm going too fast. Here it is. We're going to label this guy as plugging in an x and getting f of x. This one's going to be plugging in a negative x gets you f of negative x. Now the question is, are they the same height now? No, the y values, notice the y values here. This is x and y. But this guy is actually a negative y now, right? It's the exact opposite. It's almost like instead of going up the same amount, we're going to go down the same amount. So the question is, how are these guys connected? Oh, we say this. We say f of a negative x is the same thing as getting the exact opposite of a positive x. Okay, how are these things? Sorry, guys, whole bunch of theory behind you, but we'll jump into some problems here in a second. So what we should know is plugging in a negative x doesn't change anything because we still get the same exact function back to us. Plug in a negative x for an odd function. And what we do is we get the opposite of the function itself, or the opposite or the negation of plugging in a positive x. So let's go. How do we check these? So now let's get some problems here. Example 5, determine if the function is even, odd, or neither. All right, here's what we're gonna do. We're just gonna plug in a negative in for the x, and we're gonna find out one of two possibilities or three possibilities. One is it's gonna give us the exact same function back again. And if it does, even function. If it's the exact opposite of the function that we want, it's an odd function. And if it does neither of those, it's neither. So we have no symmetry. So plug in negative x, and you guys tell me what happens here. Negative x to the fourth, negative x to the second. It's gonna be exactly the same, huh? Because 4 negatives multiply each other, just gets you x to the fourth. And then negative x times a negative x gets you an x by itself. And so it gave us the exact same function back again. So putting stuff into the, if we want to just graph it here, so putting a little dot like in here, right, is the same thing as putting a dot in here, right? It's the same y value. Cool, even. How about that? Change it up just a second, or just a little bit here. Cool, all yours for the next one. Oh, you know, and then I graphed it here. This little guy looks like this. So do we have symmetry about the y-axis?
Yeah.
Absolutely. And then whenever you do computer graphs, they don't ever give you arrows, but there should be arrows here, right? Whenever you see a graph extending all the way to the end of something, assume there's graphs. All right, how about this one? All yours here. B, h of x. I'm going to name a different function, and I'm going to call it x cubed minus 5. All right, and you guys tell me, even, odd, or neither. You guys got it here. I love it when I trick you guys. Just want to say it sometimes. So let's go over it. Plugging a negative x in here gets you a negative x to the third power.
It should be an odd.
Ooh, let's see. So negative x times negative x times negative x is
Negative X.
x cubed. Is this guy the exact copy of the top? No, is it the exact opposite of the top?
Yes.
Ooh, I don't think so.
Oh, positive.
Yeah, so if it was the exact opposite, this would be a negative and this would be a positive. So let's do this here. If I were to, this is the way we actually do it. If I were to factor out a negative out of these guys here, notice if I factor out a negative, because this is the opposite of, and this better be the original function here, right? Does that look like the original function now?
No.
No, it's still, so shucks. So notice what we do is we factor out the negative just sort of be sitting out here in front. And if this was the original function, this would have been odd. So in this case, it is neither. There's no symmetry to this problem. And why do we need it? Because in complicated graphs, if we can find even odd symmetry, we can fill in the rest of the graph that way. That's kind of the point of finding it. Okay. And let's jam. One last one here. All yours. Oh, this is the graph for it here. So is this symmetric about the origin? No. It's because it's all the way down here, right? The piece is all the way in there. Okay, and one last one here. C, g of x. Just giving you guys a different function. Here it is. Our easy problems. The homework will have a little more tougher problems here. Negative x plugged into x to the third, and then negative x in. Now the question is even or odd?
Odd.
It's odd. Let's see. So it's negative times a negative times a negative is a negative. And this guy, negative 5 times the negative x is a plus 5x. Is that the exact opposite of the original problem?
Yeah.
Yes.
Yeah, we have to do one thing though. We have to what? Factor out the negative, right? To show that it's the exact opposite. So let's take out a negative out of this. Negative times what gives you negative x squared? Or x cubed, sorry.
Cubed.
X cubed. Negative times what gives you a positive 5x?
Negative
Negative
5x.
5.
I'll go with that. That's perfect. Okay, so now we see it here. It says this is the exact opposite of the original problem. So it's an odd problem. It's an odd function. So therefore we should be able to see symmetry about the origin. Are we good? All right, and let me graph real quick here. Did you guys ever, do you guys know Desmos.com? They ever been there? Raise your hand if you've graphed something on Desmos.com before. Okay, cool. All right, just want to see if you're familiar with it.
Used other sites to graph.
Yeah.
Or sounds familiar though.
Cool. Okay, so there's this one. What do you guys say? Yes, symmetry about the origin?
Yes.
Yeah, notice the things in quadrant 4 are the exact reflection in a sense in quadrant 2. Things in quadrant 1 are the exact reflection in quadrant 3. So that's cool. Okay, one last thing to do. I think it's one last thing to do. Maybe not. Maybe that was the last. Did we do increasing, decreasing already?
Yes.
Oh, cool. Okay, cool. Then we stop here. All right, guys, that was it. 1.5 is done. So let's jam to homework questions. Anything, let's start off with 1.3. So get out your homework here, 1.4, 1.5. And then let's see, I do have Miles. I have something for you here. Uh-huh. So do you guys remember the piecewise functions? Remember that one
Yeah.
where I said, you know
Those were pretty, I actually think the question I
what? Here's the, let's see, what do I have? I looked up the bracket. Okay, so this is, looks different now. Here's the IRS tax brackets for, I think, 2019, I think. So here's what it is. It says if you have over $9,875, then you're going to be in the 12% tax bracket. We good? Anything from 0 to $9,874, you're going to pay 10%. So notice that it's not linear, correct? It's like it's in brackets and pieces, right? From here to here, you pay that much. From here to here, you pay that much, and you keep on going. So this is a person that's filing as a single person, married individuals, and then head of household. Okay, we good there? Question is, how do you turn this into a function? That's the question. And so let me check this out. Why is this not pulling up? Man, that's no fun. Let's see if I can bring it up in Paint. Let's see. Oh yeah, okay. Oof, that's too small. Zoom. That's not the one I want. I think it's this one here. Let me bring this up in Paint as well here. No, shucks, guys. I think I deleted it. That's no fun.
What was it? 2021 brackets?
Let me do this real quickly here. That's
Why?
good there. So let's see if that makes sense here. This is probably 2017 or something like that. So a person's earning $0 to $8,025. They just pay just 10%. Good. And now the question is, how do you, as a function, how do you make sure that it's like you pay this much, but then I got the 12% only for this right here. Good. And so what we do is we say, if they made exactly, so 10% off of $8,025 is $802.50 with it. So we took care of that tax bracket here by that piece. But then this one here, it's going to be anything over that, you're going to pay 15%. And so, and then you simplify it and it becomes this right over here. So yes, we got 1, 2, 3, 4, 5, 6. We have a piecewise function that actually has 6 different functions inside it. That was kind of cool, sort of see it. Make a piecewise function out of down. Okay, we're good there. So let's go. Homework questions. Let's go for it.
Number 53.
Let's go with 1.3 first, and then we'll work our way through the other ones here. Maya, go ahead. On 1.3? Whoa. Okay. Sorry, Maya, say again.
69 and 73.
Second.
That's what I could. Yeah, they're not.
69 and 73? Yep, you got it. Eli, did you have one from 1.3?
From 1.4.
1.4, go for it. Which one?
Number 53 and number 61.
Okay, guys, any others from 1.3, 1.4? Going once, going twice. 83?
67 or 1.4 and 61.
61.
We already have.
53 is already there. Uh-huh.
Yeah,
Maya?
okay, we have 53. Do you have 57, 59, 61, and 67?
Well, 57?
57, 59, 61, 67.
Yep, got the rest of them. Cool, okay. Any others? Going once, going twice. So let's go here. 1.3 is going to be number 69 first. And let's jam. Or if you have any others, if you didn't speak up yet, you can still speak up. It's not like it's all closed here. So 1.3, number 69, it says, write the slope intercept form of the equation. So there's part A and part B on this guy. And it says, write an equation of a line that is parallel to this right here. All right, and you guys help me out, make sure I don't. Yeah, sure.
Can you do 79 for me, please?
79?
Yeah.
Absolutely. All right. So we need to fit it into this little formula right here, guys. This is the formula. It's called the point slope form. And so what we do is we do need a point to plug in, or coordinate, but we also need a slope to plug in. So I have a point that's given. The only problem is I don't have a slope. So what I'm going to do is I'm going to try to get my slope from this guy here. In order to get a slope from this guy, I have to solve it for y to put it into the mx plus b form. We're good. So divide by -3, divide by -3, divide by -3. And I got myself a 4/3 x minus 1. Are we good there? And then tell me if I'm not doing it correctly as well. So I don't care about the -1. I do care about that guy right there. So the slope that I want for my formula is 4/3 because I'm trying to figure out a parallel line. So I got myself that. So I'm going to plug in the 1 for y1. I'm going to plug in 4/3 right here and x minus 2. And I'm good to go. So 4/3 x, let's see, plus or minus 8/3. Is that right? And I'm going to have to add 1 to both sides. You guys all good on this one? Am I doing it correctly? Just checking me, okay. So go ahead, Keegan.
I got a different answer. The book said y equals 2x.
Y equals what?
2x.
Did I write down the problem correctly? I did.
No, we did not 2x plus 3.
That's what the book said.
16.
One point three.
I got 2x minus 3 too.
Mm-hmm. Okay, so here it is. How about this guy is a 2 instead of a 3? and it changes things up quite a bit. Sorry about that, guys. Let's go back. So let me erase as we go. Guess I can keep a few things in here. Just need to change what I made a mistake on here. So that changes, that changes. That changes because now we're divided by 2. Yeah, okay. Everything changes. All right. So. All right, how about 4x minus 2y equals 3? Way, way better. Let's see, let's move the 4x over. It makes the negative 2x is equal to 4x plus 3. Divide everything through by negative 2, negative 2, negative 2. And we get ourselves a, sorry guys. How about that, right? We moved the 4x over, we had a negative already. Okay, are we good now? Finally, we're good. So what we want out of this guy is just this little piece right here, just a slope. Because we want to put into our little formula here, y minus 1 is equal to the 2x minus 2. And adding 1 over this way gets us 2x minus 3. Is that good? Yay, all right. Finally, a math teacher got the correct answer. Okay, that's for parallel lines. The only thing that we got to do for perpendicular lines is the fact that this little slope, we don't want a 2 for the slope. We want the exact, let's see, opposite reciprocal. Is that right? So you guys talk to me. What's opposite reciprocal of 2?
Negative 1/2.
Negative 1/2, good. Opposite, which means the opposite sign, and then the reciprocal of 2 is 1/2. Perfect. So let me plug into this formula again. Let me just plug in a negative 1/2 this time. So y minus 1, negative 1/2, x minus 2. So how about a negative 1/2 times x? Half of a 2 is a 1, and negative times the negative is a positive. So we're good there. And you guys talk to me. Is that the same answer you guys got? Is that what the back of the book said? Does Bob agree with us? I like when Bob agrees. Okay, cool. That's 6973. Okay. All right, we're good. Can I go on to 73? I'm going to go just a little bit faster just so we can make it through all the homework questions. We're good. So 70. And I know that not all of you guys have the same questions as well. So part of it is just going fast so we can get through. So same exact problem, except different numbers here. So part A, I need a parallel line. And B would be the perpendicular line. All right, so here it is. This little guy. If you're to graph this, that's going to be a slope of 0. True, true. So if that's a slope of 0, we can still plug it into this little formula. Y minus 0 is there. The slope is 0 itself. And it's x minus a negative 1. So it has to be a plus 1 right there. And 0 times anything is still 0. And if you add 0 to both sides, it'll still be 0. And everybody okay with y equals 0. So this one's probably easier to just do it graphically, right? Because if you're at 0, if you're at negative 1, 0, if you are right there, there's my little dot. Here's what we're trying to do. We're trying to make a line that's parallel to this line, but goes through negative 1, 0. So the only line that could possibly do that is a line that goes like this right here. Okay, Maya, is that good? Is that your question? Cool. Perpendicular one. Oh no, look at this. This is the only time ever you cannot use that formula. We're good? It's not a formula problem. You can't use it because the slope is going to be undefined. So slope of 0, any line that's perpendicular to this line will have a slope of UND, which is undefined. And you can't put undefined into an equation. It doesn't work. So this is the only time you have to do it conceptually. Conceptually is, I need a line that's perpendicular to this guy going through that point right there. And that equation is going to be x is equal to -1. That is the answer. That's not by algebra. It's more like by geometry. We're good? Cool. Okay. That's a cool one. I'm glad that came up because I always talk about like use this equation, right? But then that's the only case you can't on vertical lines. Okay. 73 are good. Jamming. Let's go with it. So 1.4. Start in order, and you guys have to keep me in order. So I think 53 is the first one. 53.
But my question on this was mainly how they got 2 as an answer in the back of the book.
Okay.
Because they have 2 and negative. There's possibilities for X, but I put 2 through and it just didn't come out.
Oh, interesting. Okay. All right. So let's see. Find all the values to which f of x is equal to g of x. And I'm going to go a little faster here. So f of x is x squared plus, and you guys help me out. Make sure I don't make a mistake here. This is 3x plus 3. So in this case, I do see an x squared. I also see an x, and right away it tells me set equal to 0 and factor. That's what I'm going to do. So subtract 3x from both sides. Subtract 3. Boom. And then I do my little Xbox pattern here. So I need 2 numbers, multiply to -2, add to -1. 1 and -2. That would do it. Okay. Good there.
Oh, I
Because
see.
that's the factoring. So this would be a +1. And I like to put the little +1. So +1, -2.
So I did them separately. And what does when it said that do it so that F or
F of x equals g of x.
yes, I don't believe I understood that properly.
Gotcha. Okay. Oh boy. Let me see if I can fix that. Okay, let's jam. Next one is I think 57. Yeah, go ahead. All right, good as well. Okay, boom. Next. 57, 59, 61 in a row. So let's jam 57. 57 says find the domain of the function here. And this one I didn't talk about maybe too well in lecture here. So let's talk about it now as we do this. So first things first, with domain issues. Domain has problems if we have fractions or square roots. So fractions are problems for us and square roots are problems for us, or any even roots. So we look at this guy, does that have a fraction? Does that have a square root anywhere? No. Domain is from -infinity to +infinity, done. h of t is 4 over t. Okay, so now the question is, does this guy have a problem? Yes, it's a fraction. So the only problem that we have is, since you can't divide by zero, the question
All the
is,
numbers except zero.
so this guy's gonna be all the numbers except for zero. So I don't know, you guys talk to me. How's it written in the back of the book? It says all real numbers except for, is that the way it's
All real
written?
numbers t except t equals 0.
Perfect, yeah. So all real numbers, blah, blah, blah. I'll let you guys look at the back of the book,
All
the
real
numbers.
except zero.
Yeah.
Except t equals 0. All the other way we can say it is from negative infinity, right, to 0. And then we break it off at 0 and we go on. That's the other way to say it. That would be the interval way of saying it. Cool. And 61. Let's see if I can fit it in. So we took care of the fraction issue. And then here it is, g of, that's so funny, isn't it? G of y.
Yeah.
Y we think normally as the outside, right? But with functions, we can stick in whatever number we want or variable we want there. Okay, what's the issue with square roots? We cannot have negatives inside here. So all we do, we solve this like this. We say, hey, when is this guy going to be above or greater than or equal to 0? That's the question. When is this? Well, I think I can solve inequalities, right? We learn how to solve inequalities.
Be all real numbers greater than or
All real numbers greater than or equal to 10, right?
That's what confused
I
me because
had
in the
that.
back of the book it said 0.
Yeah,
It had a typo.
Oh,
I think so. That's
the first typo.
Whoa, that.
Bob is not always correct. What? I'm gonna just check it here. 1.4,
Yes.
61. Oh, that's weird. You guys have 0, right?
Yeah.
Hold on. Let's see what this
In
one
the
is.
back
Is
of the
this
book, it
a?
said 0.
Okay, this is not the teacher's edition. This is the exact same one I have.
My one says 10.
Yeah, all real numbers y such that y is greater than or equal to, oh, got it, 0. Got it. It's supposed to, should have been 10. Austin, what'd you have?
I got the except for equal to 0. Wait.
Should have been 10 though, right? Should have been
Oh
10.
yeah.
Weston, did you just copy the back of the book and that was it? That's it?
No.
Only that? I see a little cheating possibly happening. Jill, go ahead.
But you said except for y greater than
Except,
or include only include.
ooh, that's right. Sorry.
Wouldn't it be
Yes.
except y less
It
than-
says, yeah, all real numbers such that.
Oh,
All real numbers y such that
Greater
y is
than-
greater than or equal to
So
10.
I said except that y was less than 10, but that's still
Oh,
the
that's
same.
perfect. Yeah, that is exactly still the same. Yep, you're taking things out as opposed to just stating it in the. Okay, 67, 79, 83. Okay, 67 it is. All right, let the fun begin. So this is now f of s, and we have ourselves a square root on top. And then we have ourselves a fraction on the bottom at the same time. Just messing with you guys, that's
Literally
it.
Everything we don't want.
Yes, absolutely. Like two bad things at the same time. So we're gonna have to divide this out into different pieces here. So question is this, when does s minus 4 give us a 0? When s is equal to 4, good. Okay, so that was we don't want, is that right? So as far as domain is concerned, oh, I put a little d for domain. S cannot equal 4. We good? Then we jump to the top and say, okay, let's deal with this one now. When is s minus 1 greater than or equal to 0? When s is greater than, right? Greater than or equal to a positive 1. Okay. So now how do we write this now?
All real numbers as such that s is greater or equal than 1 except s equals 4.
Cool. Okay, so all real numbers, my little chicken scratch here, all real numbers s such that, and we got to put two conditions here, right? Such that s is greater than or equal to 1 except s equals to 4. Okay, are we good there, guys? So there's both conditions happening at the same time.
Can you have all the numbers all set as greater than 1 or and as like and then like quality dash?
If you put a slash through here, right, except s does not equal,
Or if I had like and except like instead.
yes, correct, yeah, you can do and s.
So that would be like bracket 1. And then.
Ah, cool. So yeah, if we go interval notation, it's gonna go negative infinity, and Miles said it right. It's bracket at 1. Uh-oh. Then we go union, right? And what do we do?
1 bracket 1.
Sorry. Sorry. It's s greater than or equal to 1, right? Ah, my fault. It's starting at 1, correct? Not ending at 1. So bracket at 1, going up to 4, not including the 4, right? So we have a break at 4, and then we keep on going. Cool. Are we good there?
Yes.
Oh, got a quick question for you guys. How about if I change the problem just a little bit here? So you guys talk to me. I'm going to change the problem to this.
It's negative.
It would just be s greater than 1, yeah, or greater than or equal to 1.
You good?
Can't have any negatives.
Perfect. Yeah. So this guy is going to be s greater than or equal to 1, right? This is, we can include -4, but the -4 is already included in that piece. We're good. So then it would matter. You would just say, hey, anything that's right. The 4 is x. The -4 is extra. It's already been excluded. We're good. I think we have that. Anybody taken chemistry before? Raise your hand if you took chemistry yet?
I'm taking chemistry
Oh,
now.
chemistry now. Okay, yeah. So when we do reactants, right, sometimes we have overabundance of 1, right? So that's when you calculate how much is needed of the reactants. Your limiting reactant is the important one, right? You can have gallons of water, right? But if you only have like 2 ounces of hydrogen peroxide is your limiting agent, right? Who cares how much water you have? It's kind of like the same thing here. It's that is more important, and that excludes this already as we do it. Okay, jamming. Let's go with 79. Find the difference quotient and simplify your answer. Oh, this one. Did you guys like this one?
No.
Aw.
Wasn't this an honors question?
And so what we want to find is this right here. So we'll get to know what that means in calculus. So you got to wait 2 years. But what we're going to do is we're just going to plug into the mechanics here. I just want to simplify this out. And this is kind of weird because notice we put an f of 2. That's easy to know, right? Let's put an f of 2. F of 2 is, what was that? 4 minus 2 plus 1. Everybody okay with 3? Okay, this is the weird one. We're going to plug in a 2 plus h. So I'm going to let you guys FOIL this out by yourself, but it should come out to be 4 plus 4h plus h squared. If you still need help on foiling that out, it would be x plus 2 plus h times another 2 plus h. So I think these are the honor questions. Is that right?
Yeah.
Okay. Yeah, we'll do them real quickly here. So simplified version, I got myself a 4h plus h squared. What is that? 4 minus 2 plus 1. Oh, no, hold on. I got this one as well, right? I got this one and this one. So let's see. Let me do it the way I should be doing it here. So I look for any h squareds right there. So that's the first one. Any h's. 3h. We good? And then this guy, and this guy. Plus 3. So let's plug it into this guy now. This is h squared plus 3h plus 3 minus 3, because that's what we got from over here, over h And this is what always happens here. That has to happen. And then you should be left with only H values here. And then what we do is we factor out the H. H's get canceled. And we're left with H plus 3. That's why this is an honors question. But it's honors question also because it leads to calculus. And this is the formula in calculus. We add something called a limiting agent on here, or limits, and it becomes like, that is why we have calculus. Okay, one more. 83?
I have a question. So, like, will this stuff be on the honors work in the test?
Maybe. All right, 83. We'll finish up with 83. And a little bit more difficult, of course, make it difficult for you guys. Guys, this is going to get a little crazy here. You guys ready for this? Just looking at this here. This is g of x. And you guys talk to me on your book. What is it? Because my book has this blotch on it. Is it x squared? Is it that? Is that what it is in the book?
I think so. That's how.
We'll assume so.
I think I remember.
Come on, honors student.
What is that? X squared? Jamming. So I'm gonna go like this here. This is this minus this over this. And let's see what happens here. And this is for honors questions, right? So not all of you guys have this here. So
I got tripped up when I decided to factor out immediately instead of.
gotcha. Okay. Yeah, try not to factor immediately. What you want to do is you want to simplify this little piece on top first. So common denominators would be, I think we need a 9 over here, right? And then we need an x squared over here. So I have myself a 9x squared and 9 on top here. I have a 9x squared and x squared here. So if I do that, I get myself this right here. And then what I do is I do something called keep change reciprocal, right? Or keep change flip. So this guy's going to stay exactly the same. It'll be 9 minus x squared over 9x squared. This guy gets flipped to 1 over x minus 3. And the fun begins. Because notice this guy here is 9 minus x squared. What I have to do is I have to turn it around. By turning it around, because there's a minus there, I have to go like this. I'm gonna have to turn it around with a little negative in front. All right, honor students, here it is. So I got a negative in front. I got an x plus 3, x minus 3, which is the factoring process there. And the x minus 3 is going to cancel right there. These two canceled. Final answer. All right, and then talk to me. Is that what the back of the book had?
Yes.
Yeah, they had the negative in front of the fraction instead of at the end here. All right, guys, good. So we had the 2 honor questions here. What I'll do this from here on out, we'll do notes, and if we run out of for homework questions, I'll give you guys the videos on those, right, for the most part. Okay. Otherwise, you guys have a good weekend.
So.
What is that?
Oh yeah. So a 0 with a slash through it. Gosh, yeah, I'm gonna say you have to change that because it means something different in mathematics.
I tried my best to keep.
Thank you.
I put -1 next to that.
Sweet.
If I mean, one of them I learned over the grade time, but I checked off the function. So if
That's
I
good.
did grade right,
You're good, you're good. Class lead 1.4 on your desks. Can I talk to you real quick here? Yeah, listen.
Want this now, you know that
Yeah,
it's
yeah,
wrong.
I want it back. Uh-huh, boom.
Yeah.
And I
So-
want just a couple of guys here real quick here to talk. Okay, I'm gonna ask Esther. Esther, Sophie, can I talk to you guys?
I have a really quick question.
Yeah, sure.
I was not really on school today, so I didn't finish 1.4. Can I turn the thing today?
Absolutely, yeah, absolutely. Yeah, Lily, you get a little bit of a break. You were sick, and you just turn it and catch up when you need to, okay?
You want me to say?
No, you're good, except what I had on your homework to stay.
Yes.
Oh, just write more neater on the homework, that's it.
Okay.
I know,
I know.
Wait, sorry, sorry. Which one, Jeff? What again?
just write a little more neat on the homework.
I will do that, sir.
Last year, I just wanted to get the feel of Avery and Tourette's and stuff. Did it happen quite a bit last year? Is
Only if it got really loud. They have audio. If it's really, really loud in the classroom and they're near the sound that's being very loud, they take a lot more.
Okay,
But it's often more like subtle. It won't happen unless they're like very overwhelmed or just really loud.
gotcha, okay. And as a class, do we just sort of just ignore it? for the
Yeah,
most part,
mostly.
or just kind of keep on going?
Most of the, if they say something that's kind of like funny or swearing, most kids will be like, oh, that's, yeah, they'll giggle, but it's, most of them ignore it and understand that it's,
Okay.
yeah.
Gotcha, okay, just wanted to get a sense of things. Okay.
Yeah,
Thank
Mr.
you so much.
McCullough, they sit right next to him and he tries to be like a lot less
Who's
quiet.
they? I know
Avery, that's their pronouns. They're
Oh,
them,
okay,
so
gotcha,
am
gotcha,
I.
yes, okay, yes, yes. Still trying to use
There's a few envy kids, so me, Avery, I don't know if anybody else,
Uh-huh.
but yeah, I just use they for them. Because
Sure.
Hi, I just wanted to talk about the exam next week on Monday. So, Daniel's mom and I were talking and we were thinking he normally works with, his math tutor after school on Tuesdays and Thursdays. So we were thinking maybe like have him take it home on Tuesday and then bring it back on Thursday and like work with Madison over, or like when they meet up for tutoring.
That would work with me, yeah.
Okay,
I'm
sweet, yeah.
sure, yeah, just medicine tries to see if how they know, like, as opposed to giving answers, but I'm
Oh, yeah,
sure
yeah.
that's-
Normally it's like we will guide him through it and like it's more just like if he says something wrong, we'll still write it down wrong.
Mhm. Mhm.
And then kind of explain to him afterwards, like why it was wrong.
Oh, that would be
Yeah.
perfect, okay.
Okay.
Thank
sweet.
you so much,
That's
yeah.
good.
And how's class overall? Good?
It's been good, yeah.
Okay.
He's been doing good. So that's what Madison's been telling me.
Awesome, okay.
I have
Alright.
1.1 and 1.2 here, and then this is the diagnostic test.
Jamming.
Hopefully that
You are
can
all
be
caught up.
the grade.
I'll put it
submitted.
in.
Okay, yeah. And then, sorry, I had to go and basically relearn the entirety of trigonometry
I
at
totally did.
home.
Thanks for doing so.
And then, oh, I should probably put my name on these. And then I have 1.3 homework, but I didn't bring it. I'll give it to Abe if he can give it to you.
Sure.
Whenever that, oh wait, when will that be due? Won't that just be due a week? Wednesday? Okay. Then I will, that's not a pen.
You're gonna be gone next week, right?
Yeah, I will be going.
Where are you going?
Going camping with our family. We planned it before I knew I was coming back to Sloka.
Uh-huh.
And so I wouldn't have been missing anything, but,
Gotcha.
next year, if I can
Fun.
get it.
Yeah, no.
I don't have
Fun.
pencil.
Enjoy it.
You have pencil?
Pencil. Grab that blue pin over
Oh,
there.
there.
It's a Sharpie pin, but that's
That
fine.
works, yeah. Let me just, and then I'll staple these together here.
That works, man. Yeah, just drop it right on the desk. It's fine.
All right.
Okay, enjoy the time. That'll be fun.
Yeah, thank you. That's,
Oh, great. Just drop it.
okay, yeah. All right, thank you.
So hopefully you guys want to buy